Hi, I hope the revision has been going well. You've dusted off that calculator and you're really getting stuck in. What I have done for this video is created some questions based around the most common calculator topics. I can't tell you whether they're going to come up in paper 2 or paper 3, but the likelihood of them coming up is high. So that's a positive. I've written the questions to be challenging, so do watch out for that. If it's feeling hard, it's because it's not a predicted paper. It's because I've chosen to create things to really test your knowledge, your application and problem solving skills, just to really open up discussion and make you think about how they might be trying to hide some of the topics from you. I don't know. We'll see how it goes. This is all based around grade 3 to 5. In the main, it starts at 3 and it works its way to the hardest of the questions as well. So if you are a higher student, let's come on to look at some of the crossover. The first, I think, 3 are grade 3, and then the rest of it is going into crossover anyway. Okay, let's get on with it. And fingers crossed it goes well and it's a useful revision video for you. Okay, so frequency tables are really common. This one is at grade 3, and I have another one a little bit further into the video, which is at grade 4. We're being asked to work out the total number of goals scored by the team during the season. What they're really doing is testing if we understand how these tables work. So, for example, this first row is saying that they played 9 games and they didn't score anything. So, total number scored 0. The second row, they played 10 games and they got 1 goal in every single game. So a total of 10 goals. The next one down, 8 games were played, but they scored 2 goals in each one of those games, which means a total of 16. And what's happening is that these are being multiplied together to get those answers. So once you've got all the individual rows as totals, it's kind of like chunking. We just add the whole thing together to get a final answer. So they scored a total of 61 goals that season. Okay, the second part of this question is asking us to work out the median number of goals. So if we think about what the median means, and we'll just quickly demonstrate, the median just means the middle number. Now, we have got 38 games in total. If we were to add all the games up, we've got 38 games in total. What I'm going to be doing is halving that, which is going to give me 19. So I want the number that would be in the 19th position. Now, if I look at the first row, 0 was coming up 9 times. So the first 9 numbers would have been 0, and the 10th one would have started at 1. Now, the zeros and the ones together would be 9 from the 0 and 10 from the 1, giving me 19. And I want the 19th number. So the 19th number lies here with the number 1. And hopefully I've explained that quite well. The median is a tricky little one to get our heads around. So remember, if you divide the frequency by 2, it gives you the position of where that median is actually lying. Okay, interpreting a pie chart. We are being told that the pie chart is information about some Smarties and the different colours in a particular tube. The key piece of information is here. The rest of it is pretty much just story time. But we are being told there are 8 brown Smarties. So I'm going to pop that 8 in the brown section. And then these 2 become a fact. There it is, a fact that 45 degrees is used for 8 of the Smarties. When you've got a fact, you can use the fact method. I'm being asked what is the total number of Smarties in the tube. That's all of the Smarties in the pie chart, taking up a total of 360 degrees. When you've got that, because it's a calculator, you really don't have to think about the best way to do it. You will just do multiply across and divide by the corner. That works every single time when you're using the fact method. And you would throw that into your calculator to get 64. Okay, question 3 is all about somebody that is saving some money into 3 separate pots, a holiday, Christmas, and car pot. And then we're given the ratio. So the first thing that I would do when I've got that sentence with a ratio is I would just code it out. So I've got holiday, Christmas, and then car, which I'm going to just stick, actually I might write it in full so I don't get confused. And it's 3.7.5. At the end of 12 months, Amy had £184.80 more in her Christmas pot compared to her holiday pot. Now, this line is only talking about 2 out of the 3. That means that this money is only linked to 2 out of the 3. So I'm going to abandon what I've just written and now rewrite it just based on the Christmas pot compared to her holiday pot. So we've got holiday and Christmas. It's still 3 to 7. She had £184.80 more in her Christmas pot. So if I look at the ratio, she's only got 4 more. The question is 184.80. So really watch out for those more or less than questions. When they're talking about more or less and you haven't actually got the total, it means that you work with the difference between the two. Now, using your calculator, you'll work out what you multiply 4 by to get to £184.80, which is 46.2. And that's what you would multiply on this side. Now I've got to work out how much she saved across all 3 pots in total. So I'm going to do that multiplication actually on the original one that I wrote. And then the last thing is to add them all together. So a total of £693. Okay, we can be fairly certain that we are going to see some expanding. So what I've actually done is rather than just randomly decide which 2 you're going to practice, I've just done one question at each sort of level within this topic and hoping that that will be more helpful to you than, like I say, me just picking a couple of different ones. So the first one is the easiest style of question. You will be multiplying everything inside the bracket by 5. So 5 times b is 5b, and then 5 times negative 10 would be negative 50. And it's as simple as that. As you move to the next one, there's just a little bit more to do. So when you've got numbers and letters, do the numbers first. 4 times 3 is 12. And then you've got a times a. Now that can be represented as a squared. I'll just take, that's my working out on that side. So it gets included with the 12 and I've done the whole thing there. 4 times 6 is 24. And then there's a single a that was with the 4 stuck on the end. For C, it's just more of the same. It's like putting 2 questions in one. But they're really testing these negatives as well. So you always have to be careful of that. So I'm going to multiply 7 times y, 7 times 3. Now, for this one, I've got to remember it's minus 2 times y. So it's minus 2y. And this is where most people are going to go wrong, which is why I wrote this particular question. You've got 2 negatives. What you're actually doing here is minus 2 times minus 5. Well, 2 5s are 10, and the 2 negatives create a positive. So it's positive 10. Now, this question is also saying we need to simplify. All we've done so far is the first bit, the expanding. So what I now do is I collect the like terms. I've got 7 y's, and it says take 2 y's, take 2 away. That would give me 5y. And then for my numbers, I've got 21. It says add 10. So that will give me 31. The other thing that I see really common is people trying to put these together. All right, they can only go together if they are like in the same gang. So this is the Y gang, this is the number gang. They will not come together. All right. Okay, last one is a double bracket. The difference here is that the brackets are squashed, whereas here we had a number between them. Now, there's lots of methods. And if you've seen a lot of my videos, then you will see me doing crab's claw a lot. If you are just getting familiar with this and you've not got long to go before your exam, then this is possibly a really good method for you if you're just picking it up. So the first bracket's going along the top and the second bracket's going down the side. I include the signs because if we do get a negative one, it helps us see clearly what's going on. And then we just multiply in like a times table grid. So p times 2p is 2p squared. And then here we've got p times positive 3. So just all really just get squashed together. What you see is what you do. So I've got a positive 4 times 2p. Well, 4 times 2 is 8. So it's positive 8p. And then 4 times 3, which is positive 12. The middle comes together and is simplified, hence that word simplify coming up again. 2, this is the p squared gang, so nothing is able to go with that. Then you've got 8 plus 3, or 3 plus 8, which is 11p, and then you've got your number gang. And that would be the final answer for that. And so I've done the same with the factorizing. Factorizing is doing the opposite of expanding. So where expanding has created an equivalent expression without the bracket, we are now going to put the brackets back in. And I have done a selection of the different types of factorizing questions. And then at the very end, I've also got a solve. So these really do start at grade 3 and go all the way to grade 5. So the first thing that we're going to be doing is looking at the common factors. And you are always looking for the highest times table that will go into both. So for this question, it would be 5. I would need 1. 5 times 1 is 5. I would need negative 2 to create my negative 10. 5 times minus 2 is minus 10. And I need that m stuck to it. For this one, it's the same process, there's just more happening. So I look at the numbers and the table that is common in both is 4. Now you might take 2 out because that's common, but it's not the highest times table and it must always be the highest. A is also showing up in both of these terms, so A will come out as well. Now I want to put something here that when it gets multiplied, it creates 4a squared. Well, I've got the 4 already. I've got one of the a's. I just need to put the other a in. 5 will be needed to make the 20. 4 5s are 20. I only want 1 and it's already on the outside. So I just need to add in a b. And that is factorized. Now the next one isn't as common, but there is absolutely no reason for it not to be there. So we want to be prepared. This has lots happening with the indices, which can be really confusing. First thing we want to do is the numbers. Always numbers first, letters second. So 2 is common in both. A is common in both. But we've got a cubed here and a squared there. And we have to take the highest power that's in both. A squared is in this. It's also here. So we take out that power 2. B is the highest in both. And we end up with quite a lot on the outside, don't we? Now we've already got the 2. We've already got the B. We've got a squared, but we want a cubed. So I just need an a to make that happen. I'm then going to put my 3 in that would create the 6. A squared is already there and my single b is on the outside. I just need another b to make the b squared. And if you're ever in doubt that you've done it correctly, you can just expand it back out and see if you get the answer that you are trying to work from. Okay, now the next question is where we're really ramping it up again. One of the things that I want to point out to you so far is here we've got two terms with one operation. We've got one operation, we've got one operation. These have all gone into a single bracket. Here I have two operations, which means I'm going to have two brackets. Now I'm going to do this fairly swiftly because I'm not trying to teach this to you. If you are rusty, I'm also going to put a link to a video that really goes into this method in detail, which will help you. So the first thing I do is I look at the 15 and work out what multiplies to make 15. So that would be 1 and 15, 3 and 5. I've put my brackets in. I'm then going to drop the x for my x squared. I do the signs, and again, this video will show you what's going on about that. So I know my signs will be positive and negative. I want my factors that I've just worked out to create a positive 2. Now, if I look at this, I could make a 16 if I added them. I could make a 14 if I took them away. That is not helping me get a positive 2. But this one is a positive 5, take away 3 would create me a positive 2. And that is the answer. So I've given, hopefully, enough detail to remind you of the method. But if you are feeling super shaky, like I say, use the link and go and check it out. This one doesn't say anything about factorizing. It's solving. But the technique that we need to use is factorizing. So the first step is to factorize. I will do that quickly. So it's two brackets, drop the x. I'm working on 24. 3 and 8 will make 24. I want to make 5, which is what they will do. Looking at the question, I can see it's going to be a plus and a minus. It's going to be positive 8, take 3. Now, I need each of these brackets in turn to equal 0. So x can only take one number that would create a 0 here, and that is negative 8. If I was at minus 8 and I added 8, I would be at 0. And with this one, x would have to equal 3. If I was at 3 and then I took away 3, I would be at 0. And you can see it is actually the same digit with the opposite sign, positive 3 here. And that's what they're looking for in that answer. Okay, our next question is a money question that's been combined with a percentage. Now, this is not uncommon. What you want to do with a question like this, just break it down. As you're doing the maths, those results can feed into what you may or may not do next. So first thing that I'm going to do is work out his 152 hours. So if he's earning £12.60 an hour, we multiply that to get the total. And then we're going to do the same for his overtime. That combined will give us his total wage for the month. And then we've got to think about what they're telling us. He can earn 1,040 tax-free, but will then have 28% deducted for any additional pay. So what I want to do is now take off 1,040. So I've got 1,040, which is his tax-free. And when I take that away from the total, I get 1,022.4 that we've got to deduct 28% from. So that's my next task. Now, it's a decrease. So I am going to use the original times the multiplier equals result. So the original is multiplied. Now, this is where people may make a mistake because they put a percentage here. That is not saying percentage, so we mustn't put a percentage there. We must put a multiplier there. To find the multiplier, you would do 100% take, because in this case it's a decrease, 28%, which would give us 72%. But we don't work in percentages, so we must remember to divide by 100 to get the decimal version. Put that into our calculator, and that is how much he will get once the taxes have been taken off. So it's a great method because it does all the taking away and everything for us. So now all I have to do is add his tax-free lump and the rest of it. Round for money. And that's our final answer. Now, I'm going to have a link just drop up on the screen. We've got another percentage question about to come up. If you're feeling a little rusty, this link will take you to a topic buster that I did where we did loads of exam questions. So you can practice those by pausing, having a go, and then pressing play to watch the actual solution. But there's also a flashcard at the end, and it tackles all the questions that involve increase and decrease and use this formula. There's so many questions that can link to this formula, and if you understand how it works, it can make a massive difference. So our next question is a compound and simple interest question. Now, I deliberately wrote this so that we had an opportunity to discuss the difference between the two, because people do get confused. So we've got £5,000 being invested at either compound or simple interest. We are actually being told that Bank B will pay more, but we need to work out how much more. If you're putting money in a bank and it's earning interest, then your money is increasing. So this is an increase question. So we get a tick for the increase and we get a tick for the percentage. If you get your 2 ticks, you know that it's original times multiplier equals result. We've just seen this, the original 5,000. Now the multiplier this time is an increase, so we would be adding. Remember to divide by 100 to get that decimal version. And that is my multiplier. And remember, you have a calculator, so you can do all of this in your calculator if you want to. Now, she's putting it in for 3 years. When you have a story with a period of time, then that time is a power on the multiplier. So it's like an add-on to the actual problem. So my multiplier has power 3 on it. Now I'm going to throw that in the calculator and I get £5,368.71. Now it's all about the interest they receive. So I'm also going to just quickly jot down that the interest there is the 368.71 bit. Now that's Bank A. Bank B is talking about simple interest, and simple interest is actually exactly what it sounds like. It's simple. So what the bank would do is work out 2.65% of the investment. So 2.65% of the £5,000. Now, percent means out of 100, so I can write it like that. Of means times, and I can just throw that in the calculator and it's going to give me 132.5. And that's the interest it will earn every year. So all I have to do is multiply that by 3 because it's in there for 3 years to get the total interest. Now the question told us that Bank B would pay more, and that's happened in our calculation. So that feels good. How much more means that we are just going to do a little takeaway. And that's our final answer. Okay, our next table is another frequency table question. Now, this is the grade 4 question that I mentioned earlier in the video. So we're being told a story about a veterinary practice that are going to be buying some new crates, and they're measuring the lengths of the animals coming in so that they can buy the right sizes. First question is we're being asked to write down the modal class. The modal is just another way of saying mode. Mode means most common. So the most common length is this one here because it came up 21 times. So we would be writing down the full class width. The next part of the question is asking us to work out an estimate for the mean. Now, when I see a table and that word mean, I know that I'm going to be using the MAD method. This helps me remember the steps. I multiply first, I add, then divide. So when I go up to the table, my first step is to multiply something. Now we're actually going to be multiplying across the rows, and we want to be using a number that fairly represents the group, because the reality is I don't know the numbers. I just know that there were 8 animals that fit or got measured into a length that worked in this range. So they might have been 32 centimetres. They might have been 32.4 centimetres. I don't know, and I will never know the individual lengths. So I'm going to be using the midpoint because that will fairly represent the group, and it will get multiplied to the frequency, and it's like adding 33 8 times over. Remember the mean, add them all up, divide by how many you get. So we've added up 8 lots of 33 by doing that multiplication. I'm going to repeat this now through the entire table, midpoint times frequency. And once I've done that, I'm going to add them up. Now I have to divide by how many are there. That is not the number of rows. So I'm not dividing by 5, which is the most common thing that I see when it goes wrong. I want to know how many are there. How many animals did they measure altogether? So you can either add this column to get the answer or check, because quite often it is in the actual story as well. So my last step is to divide through, and I get the answer 45. Now, a couple of things. If you struggle to work out what the midpoint would be, all you have to do is add the 2 numbers and then divide by 2. The other thing that you should always do is a quick check. Does your answer fit in the table? 45 fits beautifully into this group, so the answer to that is yes, it does. And that can give me some assurance that I may have the right answer. It's not a foolproof, but if I had come out with an answer of 145, for example, it doesn't lie in the table. There's no way I've done that right. I can go back and start checking my maths. Okay, we've got a form and solve style question. So whenever you're seeing algebra out of its normal context, quite often against shape, but not always, we know that there is a requirement for us to work out x. The question is asking us to work out the perimeter, and we have to give our answer in meters. If we look at our edges, they're all in algebra. We know the edges are in centimeters because it tells us here. So whilst it's not saying work out x, I can't get a value for this edge unless I actually know what the value for x is. So it really will be the starting point of this problem. I know that opposite edges are equal. I therefore know that 9x minus 24 must equal the 5x plus 18. That's my equation that I now have to solve. First thing I want to do is locate the smallest set of x's, bring them to the other side. It's positive that side, so it'll land is a take, and then tidy that up. 9 take 5 means I've got 4 x's left. Still got my minus 24, and it's equaling 18. And now we're in the world of our kind of comfort zone with equations. We're used to this style, and we're usually pretty good at finishing it off. So I want to get x on its own. Last thing I say, first thing I hop, minus 24 will go and land as positive 24. Tidy up. I've got 4x left, and that is going to equal 42. And then divide through by the 4, and you get your x equaling 10.5. So 10.5 will go in where the x is here, and I will work out what that edge is. I will do the same here, put the 10.5 in and work out the edge. And now I've got everything I need to help me find the perimeter. 70.5 plus 131 gives me 201.5. That takes me halfway round. I just need to double it to include those two additional edges, and I will get my final answer of 403. We've put a lot of work into getting that answer, and it would be very easy to just pop that on the dotted line and move on to the next question. However, we need to remember we had to give our answer in meters, and all the edges were centimeters. So to finish this off, I need to divide through by 100, and that will give me 4.03 meters. Okay, our next question is referencing a right-angled triangle. Now, one of the things that I really want you to remember is you have a formula sheet. On that formula sheet, you have a right-angled triangle and lots of information being linked to it. This is when you would use it, okay? We are either looking at a Pythagoras or a trig question. So the first thing that we really want to do is work out which one. Now, we're being asked to calculate the length AB. We have been given one edge and an angle. If we look at Pythagoras, these are all edges. Lowercase around the outside of this triangle is telling us this is only usable when we have edges. Whereas our trigonometry, where we've got the capital A coming up, the A here is our angle. So this helps us when we've got angles as well as edges. So this is a trig question. Now, what I want to do is just use my formula triangle against the triangle that they've given me. So let's have a look at what I mean by that. The angle A is here, and in this question, it's in the exact same place. So my A is 36. I know opposite the capital A is my little a. So I'm going to label that on. And I'm going to continue to label in exactly the same way. I need to use A in my calculation because that's what I'm trying to find. I'm going to be using B because B has a value on that edge. C is the edge I don't need. It's just there because I labeled it. So A and B are the two that I am looking for. They are here combined with the tan. Now, the way I set this up is always going to be the same. I'm not going to set it up exactly like they have. I'm going to write tan. I don't need to write capital A anymore. I know it's 36. I always write that first. Then I kind of write T for trig, if you like. On the top is my A. On the bottom is my B, which is 18.4. So really, this is like the fraction you can see, but I've kind of elongated everything within this T. The reason that I do that is because it just makes it easier to see what's going on. The next thing that I do is write down the missing variable. Now, in this question, it's A, and then I write equals. These two are side by side, so it means that we multiply them. Now, the calculator will open up a bracket. Make sure you close it before you put in your times 18.4. Now, that's what we get. It goes on and on and on. We're being asked to round to 2 decimal places, so I would cut it here. Is that 5 or more? Yes. So I shall be adding 1, and that would be my final answer. Now, I decided that I was going to do 2 trig questions because you are either going to be asked to find a missing edge or you're going to be asked to find a missing angle. And I really wanted you to just get the chance to practice both. So this is our missing angles question. We have our formula sheet to help us. If the first one didn't go so well and you want to give it another go, you can always pause, have a go, and then press play. This time my A is X. Labeling up all the sides, I've got an A a B, and a C. B and C are together here with the cos. So I've got cos x, elongate, make that T shape. Now B goes on the top, that's 8.4, and C goes on the bottom, that's 11.2. Now, remember what I said from the last question, you always write the missing thing first. Now, we're not going to be writing x equals because x isn't on its own. We're going to be writing cos x. That's the value that we don't know. So that gets written first, and it equals, and then we've got our 8.4 over 11.2. We do, however, need to get that x on its own if we're going to know what it's equal to. So I'm going to pick up the cos and move it to the other side. That will leave my x exactly how I want it on its own. I just need to remember that that cos has to land as its inverse. You know, when we travel over the equals with an add, it lands as a take. So it can't land as cos. It has to land as its opposite, which is cos minus 1. And we pop that in our calculator to get this answer. Check what they want. It wants it rounded to 1 decimal place. So it's 41.4 degrees. So remember that formula sheet is there. It's yours to help you. Okay, our next question is asking us to work out the surface area of the prism. So that means we need to find the area of all the faces. Now, the front of this prism is a triangle. It is a 6 by 4. And remember, you always divide by 2, which gives us 12. Now, the back of the prism is also the exact same triangle. So we can just multiply that back up by 2 because there are 2 triangles. And then that will give us an answer of 24 for the front and the back. And because there's lots of stages to this, I am going to underline each bit so that it's easy for me to find it when I need it. I'm now going to do the base, which I can't easily see. So if I just pop in this detail here, I can see the faces a lot better. You can now see that front and that back really easily. I'm going to do the base here, which is made from the edge 4 and 12. The area of that face is 48. And I'm then going to do this back face here, which is made from this edge and this edge, which is 12. So I've got 6 times 12, making that rectangle. And the last one that I'm going to need to find is the sloping face. That uses this edge and this edge. So there's the rectangle. And we can see now the problem is we don't have a number for that edge. So I know it's that edge multiplied by 12, but my problem is that's missing. So I'm going to go back to the fact that we've got a right-angled triangle in this shape. I've got 2 of the edges and I don't know the third. If we look at that formula triangle again, we can see that Pythagoras has the 3 edges in it. We've got 2, which means it'll help us find the third. I always recommend just transporting out the detail that we really want to look at here. We've got our right angle, we've got a 6, and we've got a 4. Looking on the formula sheet, it tells me that A and B are made from the right angle. I've got A here and B here, which makes C our missing edge. The formula tells me to do A squared plus B squared to equal C squared. I know my A is 6. I know my B is 4. And together that is the edge C squared. When I pop that in my calculator, it will give me 52. So I know that the edge of C, when it is squared, will be for 52, sorry. Now I want to know what C is. I want to know what the edge is. So I get rid of that, move it across. It lands as its opposite. And we get 7.211 and on it goes. So that value is going to get multiplied by the 12 to get the sloping face. Now, try not to round. It's tempting. It's already sitting on your calculator. So leave it sitting there and just hit the times button, and then you will not lose any accuracy. And we're getting 86.533 and on it goes. So I've done all the separate elements. I had a sneaky little Pythag in there and deliberately put in to show you that, yes, you can get a straightforward triangle question, but they can also just sneakily hide it. No mention of Pythag anywhere. And it's required to help solve this particular problem. So I'm going to add up all my answers. And I get this. Check in with how they want it rounded. It is 1 decimal place, so our final answer is 230.5 centimeters squared. Okay, our last question. We have been given a cylinder, lots of information about the cylinder, and the problem that they're asking us to work out is the density. So this is a mass density volume where mum is on the top. So that tells me that to work out a density, I'm going to need mass divided by volume. The mass is clearly given to me here, and the volume is actually the real problem. I don't have it. So I'm not going to be able to work out the density until I've worked out the volume of my cylinder. Now, this is again where our formula sheet is going to become incredibly useful. There is a section with perimeter, area, and volume. And if we look for what it tells us about volume, it says the volume of a prism is equal to the area of the cross-section times the length. We kind of need to understand what all that is. And it's certainly not telling us it's the volume of a cylinder. So how is that helping us? Well, the first thing we need to understand is what they mean by a prism. So I've drawn some 2D shapes. The reason that I've done that is because a prism is created from a 2D shape. All of my 2D shapes have corners with 2 dimensions going into them, apart from my circle, which is a little bit different, isn't it? The third dimension is a third length going into the corner. So I've now got 3 different lengths all meeting at the corner, and that is creating the prism that they are referring to. So those are the 3D shapes. The cross section is the original 2D face, and the length is the additional length that took it from 2D to 3D. So our cylinder will fall into the information given on the formula sheet about the volume of a prism. The area of the cross section for us is a circle, and that is going to be multiplied by the length that created the 3-dimensional shape. Now, the area of a circle is also given to us on the formula sheet. It is pi r squared. So now we just need to pop our numbers in. Pi times the radius is 3, and that length is 12. Pop it in your calculator, and you get 108 pi. My power 2 doesn't look like a very good power 2, does it? I do apologise, and I'm going to correct it because I don't like that one little bit. So this gives us 339.292 on and on it goes. That is what I'm going to be using as my volume to finish my question. I had got to the stage of 680 divided by, and then I needed my volume. I now have it. Now, when I put this into the calculator, remember, try not to round. Do 680 divided by, and then press the answer key, and it will put in the previous answer you had on your display. This is equal to 2.0041, on and on it goes. They are asking us to round to the nearest whole number, so our answer is 2. And that is it. So some tricky questions. I hope the walkthrough for the solutions have been useful, the reminder of the formula sheet, how things can kind of get hidden into the questions. All of that is really useful places to take our revision. So I'll do my best to try and get another video done. If not, watch out for that predicted paper. I will not be putting it together until I have seen paper 2. That way we know that prediction is full of the topics that are left. It will be invaluable. So I look forward to seeing you for that paper 3 best guess, and I will get it done as quickly as I can. And thank you for taking the time to use this video for your revision.